Let's go to question 6. Point Q lies on the curve y equals 3x squared minus x plus 1. The gradient of the curve. Here's the keywords. Gradient of the curve at Q is equal to negative 13. Gradient of the curve means the derivative of y. A. Find the gradient function. That means we are looking for dy dx or y prime. So A, y prime equals 3x squared minus x plus 1 prime. We do know power rule. Say x to the nth power prime equals c times n times x to the power of n minus 1. Keywords. Drop down the exponent and make exponent minus 1. Therefore, exponent drop down 3 times 2 times x to the first power. Also remember x prime equals 1. Constant number prime equals 0. So we get minus 1 plus 0. Constant number prime equals 0 equals, organize 6x minus 1. Let's go to B. Find the x coordinate of Q. The gradient of the curve at Q is equal to negative 13, which means y prime equals negative 13. We already figured out y prime equals 6x minus 1 equals negative 13. This is a linear function, so isolate the variable, add 1 both sides. We got 6x equals negative 12 divided by 6. X equals negative 2. Let's go to C. Find the y coordinate of Q. Basically, we need to plug in f of negative 2 equals. We will change every single x into negative 2. 3 times negative 2 squared minus negative 2 plus 1. Go to calculator. 3 times negative 2 squared minus parentheses negative 2. Then plus 1. Enter. We got 15 equals 15. Let's go to question 7. Point P A1, where A is a positive, lies on the curve y equals x squared minus 4x minus 4. Find the value of A. Remember, this is x, this is y. Let's do the substitution. Change y into 1. Change every single x into A. 1 equals a squared minus 4a minus 4. For quadratic function, remember, we always change quadratic function into equal to 0 form. Therefore, cross the river, change sign. 0 equals a squared minus 4a minus 4 minus 1. Then combine like terms. 0 equals a squared minus 4a minus 5. Let's go to calculator. Please learn how to use polyroots. Equation solver, we can only get one solution. For example, we put a squared minus 4a minus 5 equal to 0. Control menu, enter, enter, enter. You only get -1 as the solution. But if we use polyroots, we can get two solutions. A squared minus 4a minus 5. Do not put equal sign here. Directly press control menu, enter, enter, enter. We got two solutions, -1 and 5 by polyroots. A1 equals -1, A2 equals 5. Since this A is positive, we will cross out A1 equals -1. So A equals 5. Let's go to B. Find the gradient function of the curve. Gradient function means derivative. You can use dy dx or y prime. Let's use dy dx. dy dx equals d dx of x squared minus 4x minus 4. We will use power rule. Drop down the exponent. Make exponent -1. For x prime equals 1, constant prime equals 0. 2 drop down. 2 minus 1 is 1 minus 4. X prime equals 1. Then 4 prime equals 0. Then we organize 2x minus 4. Let's go to C. Show that at P, the gradient of the curve is equal to 6. Gradient of the curve, this means derivative. We know the coordinates of P. We already figured out 5, 1. Gradient of the curve means f prime of x or dy dx. If we want to use dy dx, we will write down this way. Evaluated at x equals 5. Let's do the substitution. 2 times 5 minus 4 equals 6. Or you can do f prime of 5 equals. Still, do the substitution here. 2 times 5 minus 4 equals 6. Let's go to D. Point Q, CD is also on the curve, at which the gradient of the curve is equal to 8. The gradient of the curve means derivative, f prime of x. But it says at point Q, we are given the coordinates of Q is CD. This is x, this is y. So we get f prime of C equals We will plug this c into derivative of function 2x minus 4. So 2c minus 4. 2c minus 4 equals 8. Then we solve for this c. Add 4 both sides. 2c equals 12 divided by 2. c equals 6. Show that d equals 8. d equals f of c. For any coordinate, for example, we have x, y. We will write down f of x equals y, or y equals f of x. If we have AB, means f of A equals B, or B equals f of A. Since the coordinate of Q is CD, we already figured out C is 6, D. So we can write down D equals f of 6. We know y equals x squared minus 4x minus 4. So we do the substitution. Substitute the x for 6. 6 squared minus 4 times 6 minus 4. Go to calculator. We can get 8. So we proved d equals 8. Question 8. Consider the function f of x equals 5x squared minus x plus 5. Write down the derivative of f of x. F prime of x equals 5x squared minus x plus 5 prime. 2 drop down. 5 times 2, x to the first power, minus x prime is 1. Constant number 5 prime is 0, equals 10x minus 1. Let's go to B. Show that at x equals 1, f of x equals f prime of x. F of 1 equals, we do the substitution for f of x. Every single x change into 1. 5 times 1 squared minus 1 plus 5 equals 9. F prime of 1. We will substitute x for 1 in this derivative function. 10 times 1 minus 1 equals 9. So at x equals 1, f of x equals f prime of x. Let's go to C. Find the coordinate of a second point on the curve for f of x equals f prime of x. F of x equals 5x squared minus x plus 5 equals f prime of x equals 10x minus 1. If you want to use Pauli roots, you need to move everything to the left side. Change this quadratic function into equal to 0 form. 5x squared minus x plus 5. Do not forget to change the sign. Minus 10x plus 1 equals 0. Combine like terms. 5x squared. Negative 1 minus 10 is negative 11x plus 6 equals 0. Let's go to calculator. Make sure you will use poly roots. So do not put equal sign. Just put the polynomial function, which is 5x squared minus 11x plus 6. Control menu. Enter, enter, enter. X equals 1 or x equals 6 over 5. Since we are looking for a second solution, x equals 6 over 5 by poly roots. X equals 6 over 5. Since we are looking for the coordinates of the point, we need to figure out the y coordinate. We can use f of 6 over 5 to figure out the y coordinate, which is 5 times 6 over 5 squared minus 6 over 5 plus 5. Go to calculator. We got 11. So the coordinates will be 6 over 5 or 11.